Okay, we are talking about areas between two curves. And let me start with the basic idea. We have two graphs on an interval AB, where I call the upper graph F up and the lower graph F low, F up and flow. And now the problem is we have to compute the area between the two curves. So we talk about the area that is bounded by the graph of F up and F low between A and B. Now, what is this area? That is the area of this rectangular line. Now, the length of the line, if I fix here an X, is F up of X minus F low of X. Yeah, where F up of X is the length of this line and F low of X is the length of this line. And if I subtract these two, then I get the area of the red line. So this is the length of the rectangle. Now the width is a small increment in X direction. So what you have here, that is the area of the red rectangle. And now you do this for all X between A and B. And you sum it all up. So the integral sign is a capital S, that stands for sum. You sum it all up for all X between A and B. And this gives you then the area between the two curves. So that is the main idea. And now let's do an example. There we find the area bounded by y equal to 2x and y equal to x squared for x between 0 and 3. So the first thing in all the problems, we produce a graph. Then we have y equal to 2x. Not a good graph, apologize. We have y equal to x squared. And we have y equal to 2x. Now 2x is equal to x squared when x is equal to 2. And if x is equal to 2, y is equal to 4. And at 3, here y is equal to 6. And here y is equal to 9. So what area are we talking about? The area between the two curves is the area in this region here, which is bounded by the line and the parabola. And then between 2 and 3, it's this area here. Maybe let me draw this again to see it better. So we have the parabola, we have the line, here is equal to 2, 4, 3, 6, and 9. And we talk about the area between the two curves as this area and this area here. Maybe good that I messed this up first. The important thing is that you have a good sketch. If your first sketch is not good, look at your calculator, at your graphing calculator, and produce a halfway decent sketch. Now, the thing here is y equal to 2x, and this is y equal to x squared. So what is the area between the two curves? So you have to find an upper curve and a lower curve. Between 0 and 2, the upper curve is y equal to 2x, and between 2 and 3, the upper curve is equal to x squared. So how do we find the area between the two curves? First, we fix an x between 0 and 2, and we compute the area of this little rectangle, of this rectangular line. The area is the upper curve, which is 2x, minus the lower function, f low, which is equal to x squared. That is the length. You multiply this with dx, that is the area. And now you sum up all the areas between 0 and 2. Now we go between 2 and 3. So we fix an x here. Then this is the rectangular line. The length of it is the upper curve minus the lower curve, x squared minus 2x. You multiply it with dx, and you do it for all x between 2 and 3. And that gives you now the area between the two curves. If you want to compute this area, you either use your calculator and use the definite integral, or you do the antiderivative, plug it all in, and you compute the area. In most cases, the problem will say set up the integral, but do not evaluate the integral. You don't have to evaluate it. Okay, that was the first example. Now let me do a second example. Again, I do y equal to 2x and y equal to x squared. But now I just do it between 0 and 2. So I look at this region here, and I want to compute again the area between the two curves, this thing here. But now I don't take vertical slices. What I do now is I take horizontal slices. So I look at a line of this form. So I fix here a y between 0 and 4, and I compute the area of this horizontal rectangle. So in this case here, I have to compute what is this for a value and what is this for a value. So what is the right and what is the left x here? So in order to compute the length, I have to know the value here and the value here, and then the difference is the length of this line. So now let me solve this for x. If y is equal to 2x, then x is equal to y over 2. And if y is equal to x squared, then x is the same as the square root of y. So in this case, the right x is the square root of y, and the left x is y over 2. If I fix here a y, the right x is up to here, which is the square root of y, and the left x goes from here to here, which is the x, the left x value, which is then y over 2. So what is the area? It is the right minus the left. So it is the square root of y minus y over 2. That is the length of this rectangle. The thickness of this is a small increment in y direction. And I do this for all y between 0 and 4. Okay, I claim the value of this integral is the same as the area of this integral. It is the same area, just the first one you set it up with vertical slices, and the second one you set it up with horizontal slices. So let's compute with the fundamental theorem what this is. The antiderivative of 2x is x squared. The antiderivative of x squared is 1/3 x cubed, where you plug in 0 and 2. So it's 4 minus 8/3, which is the same as 4/3. And this thing here is the same as y to the 1/2 is y to the 3/2 times 2/3, and minus y over 2 is minus y squared over 4, where we plug in 0 and 4. Which is the same as 2/3 the square root of 4 to the 3 minus 4 squared over 4, which is the same as 4 to 8 16/3 minus 4, which is 12/3, which is 4/3. So yes, both integral, also they look entirely different. They describe the same geometric object, namely the area between the two curves, so they give the same value. And that concludes the lecture on areas between two curves. Thank you.